Hi, hello everyone. My name is Shidong. I'm the account manager at CST Learning Technology. Welcome to today's CST Learning Lab live session. Today I'd like to introduce Chris Grange, who's one of our IHC scientists at CST Learning Technology. Chris has close to 10 years of experience working with a varieties of immunohistochemistry techniques and different platform and technologies. His main focus right now and over this time with CST has been the development and validation of IHC-grade antibodies in a number of research areas. Today, we're going to discuss how antigen retrieval and your choice of antigen diluent can impact your IHC experiment. During both live sessions, we actually have another one in the afternoon. You will also have the opportunity to ask questions by typing them into the GoToWebinar question area in your control panel. By the end of the presentation, Chris will be available to answer some of the questions you have. For those of you who are just joining us, welcome to CST Learning Lab live session again. Without further ado, I'm going to hand it over to Chris.
Today, I will briefly discuss two important considerations in the IHC assay: the antigen retrieval process and the choice of a primary antibody diluent. After the presentation, I'll be happy to answer any questions that you may have. As everyone is likely aware, the IHC protocol involves a number of steps that can impact the results of your assay. Before you even begin your staining experiment, many of these pre-analytical steps have already occurred. These include tissue grossing and sizing, fixation, processing, embedding, and section. The analytical steps of the assay are listed here, and while all of them can have an impact on the quality of your staining, we will only be focused on antigen retrieval and the primary antibody diluent today. I want to briefly touch on the fixation step before we get into antigen retrieval. Fixation is the preservation of tissues that allows for subsequent processing, embedding, sectioning, and staining. It is the creation of methylene cross bridges within and between proteins that provides the structure and rigidity necessary to preserve tissues in a lifelike manner and help them to withstand treatment with various reagents during the IHC staining protocol. In IHC, the most common fixatives are 10% neutral buffered formalin or 4% paraformaldehyde. One of the most common issues regarding fixation is an extended cold ischemic time, wherein the tissue is excised and not immediately immersed in fixative. Another issue is the time of fixation. As you can see in the image on the right, underfixation can lead to a fairly drastic drop in signal intensity. At CST, we fix all of our mouse tissues in-house. We use 10% NBF and fix for at least 12 hours, being sure that the tissues are cut into smaller pieces if needed. Overfixation is less likely to cause major issues, though tissues should not be allowed to sit in fixative for extended periods of time. It is the creation of methylene cross-linking during the fixation step that necessitates antigen retrieval. As you can see in this simple diagram, the cross-linking between blue and red proteins is blocking the epitope where the antibody is attempting to bind. Through the use of heat-mediated antigen retrieval, we can break that cross-linkage, which allows the antibody to bind to its intended target. The two most common antigen retrieval methods are heat-induced retrieval and enzyme-mediated retrieval. Enzyme-mediated retrieval utilizes proteases to cut the fixed proteins in various locations, which can allow the antibody to access blocked epitopes. We will focus on heat-induced epitope retrieval today, as it is by far the most common method. There are three major considerations when planning your antigen retrieval step. The first being selection of the heating apparatus, followed by the time and temperature of your heating step, and finally, the selection of your antigen retrieval buffer. In our testing here at CST, we have found that the use of a hot plate or water bath is not a good option for antigen retrieval. We tested a number of different antibodies with hot plate and water bath retrieval, and in nearly every case, the signal intensity was below acceptable levels. It is likely these devices are either incapable of reaching a sufficient temperature or the heat is dissipating too quickly. At CST, we recommend the use of a microwave for the majority of our IHC protocols, as in nearly every case, we are able to achieve sufficient signal strength when performing antigen retrieval on sections stained with well-validated antibodies. As such, we often recommend the microwave, as it is a common piece of equipment in most labs. We have found that a pressure cooker or decloaking chamber can yield more robust retrieval than the microwave, and as such, we recommend its use with a few of our products in order to maximize the signal strength. The next consideration is the time and temperature. When performing IHC here at CST, we always bring the slides to at least 100 degrees Celsius. In the microwave, it can be a fine line between heating the slides to a rolling boil and getting too much buffer evaporation. Since we need to avoid drying out the slides, we achieve a rolling boil at high power in the microwave, then reduce power and maintain sub-boiling temperatures. If, when optimizing an antibody, the signal strength is suboptimal, one option is to increase the antigen retrieval time. Keep in mind that tissue degradation can occur when the antigen retrieval step is lengthened. The final consideration for antigen retrieval is the choice of buffer. The two most common buffers are sodium citrate, which is generally used at pH 6, and EDTA, which is commonly used at pH 8 or 9. Generally speaking, the higher the pH of your buffer, the more robust your retrieval will be. As you can see in this example of our anti-IBA1 product, stained on mouse brain, sodium citrate yields an acceptable signal level, though the Tris EDTA and EDTA buffers are stronger. A similar result was also observed with our anti-BCMA product on normal human colon. For the most part, we have found that nearly all well-validated antibodies will work with either sodium citrate, EDTA, or both. One important point here is that if an antibody is recommended with sodium citrate, it will work with EDTA, though you may have to adjust the primary antibody dilution if the increased retrieval efficiency leads to some additional background signal. If an antibody is recommended with EDTA, there is no guarantee that you will achieve sufficient signal strength with citrate buffer. So to summarize my main points regarding antigen retrieval, use either a microwave or pressure cooker to heat your slides, and remember that the pressure cooker will often yield more effective retrieval. Always bring the slides to at least 100 degrees Celsius. Sodium citrate and EDTA are the best options for retrieval buffers, and EDTA will yield more robust retrieval. Based on what I have covered here, if you have an antibody that is yielding very weak signal, the best option to maximize retrieval is to use EDTA buffer in a pressure cooker. And if you choose to alter our antigen retrieval recommendations, you may have to perform additional optimization steps. I would like to switch gears here and briefly discuss why it is important to select an appropriate primary antibody diluent. In my experience, it seems that many researchers believe that the primary diluent has very little effect on the signal intensity of any given antibody. And while I agree that some, and perhaps the majority of well-validated antibodies will work with just about any diluent, we have seen some exceptions. As an example, I heard from a customer who was unable to achieve any signal with our CD3 antibody on mouse spleen. And after a discussion about his protocol, it was revealed that he was using a diluent purchased from another company. I was skeptical that the diluent could be causing such a drastic reduction in signal, but suggested he try our signal stain diluent to see if that might be the issue. He did, and as you can see, this antibody is extremely sensitive to the choice of primary diluent. The tricky part about this is that it is impossible to predict which antibodies might be sensitive to the choice of diluent and which may not be. If you desire to use a different diluent with CST antibodies, my recommendation would be to first compare it with signal stain antibody diluent to determine if the performance of an antibody is affected by your choice of diluent. With that, I would be happy to answer any questions that you have that have come in during the talk. And please feel free to continue submitting questions, and we'll see how many we can get to. Thank you.
Awesome. Thank you very much, Chris. Again, just a reminder, if you have any questions, you can actually type them into the GoToWebinar question area in your control panel. And right now we have some questions in the queue, and Chris is actually here live with us today. Hi, Chris.
Hey, Shidong.
Awesome. So let's go through some of the questions. Let's see. Okay, so the first question is, if it's a brand new antibody that I'm going to work with, how do I know which antigen retrieval to use if I've had no previous experience with this antibody?
In a case like this, if the antibody is recommended for IHC, then there's really no reason not to use the manufacturer's recommendation for antigen retrieval. But if it's an antibody that is not recommended for use by the manufacturer and you're attempting to validate it, there's a couple different ways you could go. I'll tell you, at CST, what we do is because we are do such high throughput IHC, we always start using sodium citrate buffer at pH 6 and heating in the microwave. So, my recommendation would be, I know that through our experience that's a great antigen retrieval step to use, and it works with nearly, every well-validated antibody we have. So, that would be my recommendation. Start with sodium citrate in the microwave. If you find that the signal intensity is weaker than you would like, then you could move on to EDTA in either the microwave or a pressure cooker to increase that signal.
Awesome. Moving on to the next one. Okay, so the question is, should I use a heat-mediated retrieval versus protease digestion type of retrieval? Chris?
Again, if the antibody manufacturer recommends enzyme retrieval, then it's probably a good idea to attempt that first. But if they don't, then I would always recommend using heat-mediated retrieval as your first option, because it's by far the most commonly used retrieval method, and it's a good starting point. If you absolutely need to get that antibody to work and you're not seeing sufficient signal with heat-mediated retrieval, then it may be worth it to try enzyme retrieval. But to be honest, we rarely use enzyme-mediated retrieval, and we see a lot of success with heat.
Thanks. And okay, so we have a specific one about our signal stain diluent. I think the question is, what is the unique features about our signal stain diluent? Anything to do with pH, maybe? Can you share some more details, Chris?
So the recipe for the signal stain diluent is proprietary, but we know that it has strong buffering capabilities, and so we think that's one of the benefits of using signal stain as opposed to diluents available from other vendors, or diluents that might be made in-house.
Got it. And there is a question about a very specific antibody regarding diluent sensitivity. I think we will be able to get back to this question offline because it's very specific, but we will have answer for you. Moving on, the next question. Oh, so it's, is there a retrieval method that does not use either heat or protease?
Not that I'm aware of. I know that we at CST have not, we've not tested, or I don't believe we've come across a retrieval method that doesn't use heat or protease.
Got it. And also in regard of retrieval, any suggestion on how to prevent the tissues from falling off the slides during the retrieval step?
Yeah, that's a good question. We come across this issue occasionally at CST, usually when we're using fatty tissues like breasts or breast cancers, and we're heating in the microwave. One thing you could do is try baking the slides prior to your staining protocol. And I would recommend like 60 degrees Celsius for an hour. That can help the tissues adhere to the slides a little better. And I would also be sure that you're using charged slides or polyol-lysine coated slides as well.
Got it. All right. Let's see. Okay, I just want to say there's a question about sections of different thickness. We will also address that separately offline because we have a little bit more information to share about this, but thank you for the question. I'm looking at, okay, again, on antigen retrieval. Is there any difference in antigen retrieval parameters like time and temperature, like you mentioned, when you're dealing with chromogenic versus a fluorescent detection?
Yeah, that's a good question. Our main focus is chromogenic detection here at CST, but we have done a fair amount of IHC using fluorescent detection on FFPE tissues. And in our experience, we haven't found a difference, or we haven't found that you would need to use different time and temp parameters depending on whether it's chromogenic or fluorescent. You know, if you're using the same antibody and detecting it chromogenically or fluorescently, I would say you do not need to change up your antigen retrieval method.
Got it, thanks. All right. Okay, so there's a question about that multiplexing IHC assay. And the question is, what should I do in a multiplex IHC assay if I have antibodies that are recommended with different antigen retrieval conditions and protocols?
Yeah, that's another good question, and it's something that we come across here at CST as well. So if you have a number of antibodies you want to use in the same assay on the same tissue sections, and some are recommended with, let's say, citrate buffer, and some are recommended with EDTA, my recommendation would be to go with the antigen retrieval protocol that's going to give you the most robust retrieval. So basically, if you have an antibody out of your selection of 5 or 6 or however many antibodies that's recommended with EDTA, then use EDTA for all of your sections, right? So what that means is you're giving yourself the best chance of getting sufficient signal with every antibody that you're using.
Got it. Thanks. All right, the next question is about diluent. Question is, can the diluent affect the staining patterns and localizations of an antibody as opposed to the strength of the signal only?
That's something that we haven't seen a lot of. I will say you're more likely to see differences between, you're more likely to see differences in signal strength between different diluents than you are localization. There may have been 1 or 2 cases in, the thousands of antibodies we've looked at that the localization may be affected by the diluent, but I would say it's quite unlikely that you would see that.
Gotcha. And okay, here's another one, and is how stable are CST antibodies after they are diluted into the buffer?
Yeah, so I will say that we always recommend that you make your dilutions fresh if possible. We've done a couple different stability studies with a few CST antibodies and found that they, if you dilute them and store them at 4 degrees C, they can be stable for an extended period of time, but I do not believe that every CST antibody is going to be stable for an extended period of time. So, if you need to dilute an antibody and store it for a month or two, my recommendation would be to, perform a time course study. So make a dilution, once a week and store it in the fridge. And once you get to the end of your time frame, whether it's 4 weeks, 6 weeks, 8 weeks, take all those dilutions you've made, run them versus a dilution that you made fresh, and see if you're getting any loss of signal. If not, then it's good to go, and you can dilute that antibody and store it and use it. And if you do see loss of signal, that it's not going to be possible. You'll have to make your dilutions fresh every time.
Got it. Thanks, Chris. All right, I think the next question is about autostainers. So the question is, any tips, just general tips on optimizing the antigen retrieval conditions in a automated IHC assay?
Yeah, this is a good question, and we at CST have a Lycobond RX in-house, so we have some experience optimizing our antibodies in an automated setting. So the first thing I'll say is that based on my experience talking to researchers and talking to customers, it's standard practice that you would use an EDTA buffer on autostainers. And I think that the reason for that is the way that the slides are heated in autostainers. I know that on the Ventana systems and on the Leica system, they use metal heating pads underneath the slides. And while they bring the slides to about 100 degrees C, I found that the heating step is a little less robust than you would get in a microwave or a pressure cooker, because you're not bringing the slides to a rolling boil. So in order to overcome that less robust heating step, it makes sense to start with the EDTA buffer. So on the Lycobond, that would be, for example, the ER2 buffer for 20 minutes at 100 degrees C. On the Ventana, you would use the CC1 buffer, which is their EDTA buffer, with their standard time and temperature.
Got it. Thank you, Chris. We actually have more new questions coming in. This one is, what is the best way for deparaffinizing when you're dealing with staining for fat tissues with a fluorescent dye?
Well, I mean, at CST, we basically, in our manual IHC assay, we always deparaffinize using xylene. So we'll do we'll put the slides into xylene for 5 minutes, and we'll do that 3 times. And generally that's sufficient to deparaffinize all the tissues that we work with, including, fattier tissues. After we deparaffinize with xylene, we'll then go through a series of graded alcohols and then wash the slides and then continue with our staining protocol. I know that on the Lycobond, they don't use xylene exactly, but it's a similar reagent, and it again seems to do the job just fine. So I think your standard xylene deparaffinization should be sufficient.
All right, so next question is, are there any advantages of a concentrated antibody over RTU? I believe that's ready to use formulated antibodies.
Yeah, I think that using a concentrated antibody gives you more control over your assay development and optimization. So for example, if you buy a ready-to-use antibody and you happen to run a protocol where that antibody looks very weak or you're getting no signal, there's not much you can do there. I mean, you can mess with your protocol to try to get it just right, but you can't really change the concentration of the antibody, right? Because it's already diluted to what the manufacturer thinks is the optimal dilution. But like I said, that may not be the optimal dilution for your assay specifications. So yeah, I think that using concentrated antibodies gives you more control and lets you use whatever dilution is necessary for your specific assay.
Got it. And next question is, you introduce a little bit on how CST IHC primary antibodies perform better than some of the competitors.
Yeah, I mean, we pride ourselves on antibody validation, and you know, I can give a couple reasons why we think that, you know, why we have so much faith in a CST recommendation, especially for CST antibodies recommended in IHC. So we do all of our validation in-house. We have, you know, our mantra is that one assay is not sufficient to prove antibody specificity. And we have, you know, a pretty well vetted system we go through, wherein we'll often start with cell pellets, either, you know, transfected cell pellets or an endogenous plus minus model. And that's sort of our first pass to kind of whittle down all of our clones to, you know, sort of the best ones at that first pass. And then from there, we'll do a small titration on a few different tissues that we think, you know, maybe high or low, or positive or negative based on, you know, the literature, based on publicly available RNA data. And from there, if we believe that we're seeing, you know, the correct localization and specificity of the antibody, we'll then test on a tissue microarray, and that gives us the chance to test, you know, 50 to 70 different tissues on one slide, and that really is a big part of the reason we trust our IHC recommendations so much. Every antibody that we recommend is tested on, you know, 50 to 70, like I said, 50 to 70 different tissues. Even our mouse specific antibodies are tested on, you know, all of the normal tissues in the mouse, in addition to, you know, a number of different syngeneic mouse tumors. So, you know, that gives us a lot of confidence in what we're doing. And we try to put as much of that data on the website as possible in the form of, you know, IHC images. And if customers would like to see additional data, or if they have additional questions, then, you know, they can always contact us through our technical support channels, and we'll be happy to provide additional data, or as much additional data as we have.
Thanks, Chris. And I just want to mention that there's a follow-up question about the fat tissue staining that we were discussing previously, and we will gather some more information and we'll reach back out to you offline to provide you the help. So thank you very much for the follow-up question. We still have a couple of more minutes, and I'll squeeze in a couple of more questions. We actually have some. One is, any thoughts on how CST antibody diluent performs with different commercial detection reagents, be them automated or on the bench type?
That's a good question. I'm not entirely sure. We generally use, you know, obviously the reagents, the chromogens, and the secondary boost antibodies that CST sells. So we don't have a ton of experience using our diluent with, you know, other reagents in an IHC assay. I do not think that the diluent would have much of an effect on like a secondary antibody or, you know, a DAB detection system. But without, you know, having done enough testing to determine that, I can't say for sure.
Thanks. All right, one more. I think this is on auto stainers. Does CST plan to come with doing some in-house validation on Ventana protocol, just like what has been done on Leica Bond?
Yeah, at this point, it would probably be a while before we're able to optimize our CST antibodies on the Ventana platform. right now we have the LicaBond RX in-house, and that's what we're using. We have over 100 IHC recommended antibodies optimized on the bond, and we provide those protocols on the CST website. As for our customers that are using the Ventana platform, again, if you get in contact with us through technical support, we can offer some tips for optimizing CST antibodies on that platform.
Gotcha. Okay, I just want to another mentioning to a question about nanostring, because it's a very specific technology. We will definitely reach out to you offline with the information you're looking for. Thank you for the question. All right, the next question is any advantage or disadvantage of using the DAB substrate?
Well, the DAB substrate is what we use routinely at CST, and there are some advantages to it. One, it's known as to be like one of the crisper substrates, so there's less, sometimes with other substrates you can get some diffuse signal, but DAB is generally quite crisp. It is, a permanent substrate, so that's nice. It's not water soluble. It's not going to fade over time. And so, those are the main reasons that I believe it's, one of the best options. But if you're looking at negatives, for one thing, the color is brown. And if you're working with something like melanoma tissues that have pigment, it might be difficult to determine what's, actual staining and what's pigment. And it's carcinogenic. So if you're thinking about, health and safety, then that's something to be considered.
Thank you, Chris. And we have another one, which is about the CST signal stain boost detection kit. So the question is, what's the major difference between the AP and the HRP detection kit? And I think it's mentioned that the HRP signal boost is seeing more use, it's more commonly used. So what's the difference here?
Yeah, this goes back to the question I just answered about the DAB. So the HRP secondary, the HRP boost reagents should be used with DAB. And as I mentioned, DAB is the primary chromogen that we use at CST. So that's why the HRP is used so much more often. But we recently came out with the alkaline phosphatase detection kit. And so that would be, a good option for, like I said, using melanoma tissues. You could use the alkaline phosphatase detection with the red chromogen, and that would give you some nice contrast in certain tissue types.
Thanks. And a general question about antigen retrieval. How does antigen retrieval step affect background? And if there's any impact on background, how can that be addressed?
It certainly can affect background staining. As an example, if you're using an antibody at, let's say, 1 to 100 with EDTA antigen retrieval, that might give you really strong specific signal, but it could also bring up some additional background signal, some additional, haziness within the tissue. So there's a few things you could do in a case like that. You could either titrate your primary antibody out to 1 to 200, 1 to 400, and see if that alleviates the background signal while also maintaining sufficient specific signal. Or you could try a less robust antigen retrieval step, so something like sodium citrate as opposed to the EDTA, and see if that gives you better signal to noise.
Got it. Thank you. I think that's the last question, and we're a little bit over on time. I just want to thank everyone again for joining us today and for asking those great questions. If you have any other questions, feel free to email us. You can always reach out to us through our support group or pretty much just email cell signaling, and we will be able to get back to you as soon as possible. Again, thank you for joining us, and thank you, Chris, for answering the questions. I hope everyone have a great day. Thanks.
Thanks, Shidong.